look at the following problem. So who solved this question? This one is pretty hard. C. C, 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 C. Okay. I think C. C. Okay. I think most people here are saying C. Someone said emotional damage. That's not one of the choices. C, C, C. Yep. Okay. I think everyone's saying C. Well, then someone tell me why you think C. Why do you think C and not like 22 or 24 or something? C what? That's great. What a pun.
I did it because I added up. There's five black squares on this side, so I added up the other side, that equals 10, and 4 on the other side, that adds up to 8, that equals 18, plus the other side, that which is 1, that equals 20.
Yes, I would say that's pretty much the right process. Yeah, that's right. Does anyone else want to share their solution? Okay, Jasper says, well, you can see 3 sides of the cube with the cube has 6 sides. So I counted all the black squares and then multiplied it by 2. Yep, that's pretty much right. So to elaborate on what you guys said, basically the idea is that if you look at all of these squares, you see that there's no overlap, right? What that means is that with any single cube that you see, there isn't a cube with 2 sides painted. What this means is that if there's no overlap, and with every opposite face the same, you can safely multiply by 2 without overcounting the cubes. Right? Does that make sense? So, you guys good. Angela, are you okay? What do you not understand? Well, let me know if you have a question. But again, the idea is that for every single face, you only have the same number of painted squares. And since there are no overlaps, you can just multiply by 2 and you're good. Okay, well, I think we're okay. Does anyone have any questions about this problem? Going once, going twice, going 3 times. Okay, no. All right, let's go. So now here's 4 more problems. All of them a bit more challenging. But a lot of what we talked about earlier actually applies to this. So remember, first, look for patterns, look for pairs. And second, look for the greatest and the least possibilities. And good luck. I'll give you like 5 or maybe 7 minutes. We'll see. All right, we're gonna wait for like 2 more minutes. If you're really stuck on a question, you can ask me and then I'll give you a hint so that you're not stuck just sitting there. But 2 more minutes. May you please give me the answer to number 8? Number 8 is pretty tough. Try your best. We'll talk in like 2 minutes, okay? I would say, as a hint for everyone, for problem 8, you want to consider the least possible scenario and the greatest possible scenario, and then see what the answer is. It's pretty obvious, actually. Hey, that's okay. You don't have to solve every question. We'll talk, okay? We'll talk about it. From my experience, AMC8 really doesn't have that much trick questions. Definitely don't overthink it, but usually they're pretty straightforward. I mean, straightforward in the way that there's no trick questions. Well, I'll just say it's not E. There is an answer. It's not E. I repeat, the answer is not E. All right, we're gonna wait 1 more minute and we're gonna start talking, okay? Finish the problem you're on. All right, ladies and gents, let's take a look at this. Did anyone solve this problem? Did anyone get an answer other than E that I would like to share? Timmy says C. No, no, C, no, okay. Kimmy, do you want to tell us how you got C? Okay, well, there's actually a way you can solve this without just going into the mess. So what you want to do, again, you just want to consider the possibilities, right? Because, okay, let's say this. Let's say that A and B are as small as possible, and they're both 1, right? They're both 1. So you have 9, 8, 7, 6. Actually, I'm not even going to write it out. It's so easy. So you have 1 here and 1 here, right? If you have 1 here for both of these letters, you see that 7, 3, 1, when you add these together, it's a 1 and it carries over once, right? So when it carries over, 1 plus A plus 1 plus 1 gives you 11. So it carries over again. That's 5 digits. So if A and B are as small as possible, you're going to get 5 digits, right? So maybe that means something. The answer is probably not 4 then, right? Because if A and B are as small as possible and you already have 5 digits, then you definitely cannot get 4 digits. So cross that out, right? Now let's look at the other possibility. What if A and B are as big as possible? What if they're both 9? Then in that case, what you have is this. You're gonna write 9 and 9. And again, you have the 1 that carries over. Now you have 1 plus 8 plus 9 plus 9. Now what that gives you is 18 plus 9, which is 27. So that's 7, and a 2 carries over. That's 11. Again, 5 digits. So if you have A and B maxed out, you also have 5 digits. So that means you can't get 6 digits. And you can't get 9 digits because if A and B are already so big, they cannot get any bigger, and you still only have 5 digits. How on earth would you get 6 digits, right? It's just common sense. So clearly the answer is 5, because no matter how small or how big A and B are, they always give you 5 digits. So that means it actually doesn't depend on the value of A and B, because you can give me A and B for any digits and it's always B. Does that make sense? Any questions? Okay, guys, this is really just like your basic. When do you guys learn this in elementary school? 3rd grade addition? 2nd grade? 1st grade? Or is it 4th grade? I can't remember. 3rd grade, 2nd grade. But basically the idea is that you just have 3rd grade addition, except with A and B. So what you really just have to do, you just have to, like try 2 possibilities, try the smallest possibility, try the greatest possibility, and you'll get your answer. I know it doesn't say plus, but the word sum implies it's an addition problem, right? Because if you have a bunch of numbers added together, the answer is called a sum. And you have a subtraction problem, the answer is called a difference, right? If you have 2 numbers multiplied together, it's called a product, and 2 numbers divided is called a quotient. So yeah, these are useful terms to know. Are there any questions? No questions? All right. Okay, let's look at this problem. It's a little tricky too. Did anyone solve this? Kind of. D. Okay, Kimmy says D. Does anyone else have any other answer? You guys can just feel free to unmute. You don't have to type everything. Okay, that's one solution. C. Okay, Sean says C. C. My brain was too focused on telling me that number 8 was E. Okay, I think we either have D or C. Okay, can someone tell us how they got the answer C? Explain their solution.
I did it by doing 2 times 3 times 4 times 5 times 6 times 7 equals 420.
Okay. I think you're on the right path in that you're trying to multiply the numbers to get a common denominator. But first of all, you want to note that even if you do multiply these together, oh no, you'll get 5040, right? If you multiply these numbers together, you get 5040, and that's E. And that's not correct. But even if it did end up being 420, the actual thought process is that you don't actually have to multiply these together, and the answer ends up being C. Because if you think about it, what is a least common denominator? It's the least common multiple in the denominator, right? You want the number that is the least common multiple of all of these common denominators. So that means if you have a 2 and a 4, your common denominator isn't 8, right? I think we can all agree on this, right? If you have a 2 and a 4, your common denominator isn't 8, right? It's really 4 because 4 is a multiple of 4 and 4 is a multiple of 2, right? Because when you have two numbers that share a factor, you don't simply just multiply them together, right? So now a more systematically correct way to do this is to use these numbers prime factorizations. Does everyone here know what a prime factorization is? Yes, okay, that's good. Basically, you want to write these numbers in terms of products of prime numbers, which means that with 2, you have just 2 to the first power. With 3, you have 3 to the first power. 4 is 2 to the second power. 5 is 5 to the first power. 6 is 2 times 3, both to the first power. And then you have 7 to the first power. And then when you want the least common denominator about it, what you want to do is you want to look at each prime factor, and then you take the greatest exponent for that factor. For example, let's start with the 2, right? 2, if you look at all of the exponents, for 2, it's just exponent 1, right? It's raised to the first power. But when you have the 4, it's actually raised to the second power. So you want to take that and write it here. So 2 to the second power, right? And then you look at 3, and the greatest exponent for 3 across all of these numbers is just 1. So you write the 3. The next prime number after that is 5, and you see that the greatest power is 1, so it's 5. Finally, you have 7. Note that we're not looking at 6 because 6 is a product of 2 and 3, and we already accounted for these prime factors, right? So now if you multiply these together, you get 4 times 3 times 5 times 7. On the AMC, you won't have a calculator for this. So what you want to do is, again, group these to be nicer numbers, right? 4 times 5 gives you 20, and then 3 times 7 gives you 21. So multiplying these together gives you 420, which is C. So anyone who answered C is correct. But everyone else, you're on the right track too. You just, you have to account for the fact that some numbers have multiple factors and you can't repeat them because you don't need to. And if you do, it won't be the least common denominator. Does anyone have any questions about this? Prime factorizations come up quite a lot in AMCA because most of the number theories questions in AMCA can be solved with prime factorization, so it's important to understand this. So again, if you have any questions, speak now. Going once, going twice, going 3 times. No questions? Wait. Jasper, we're waiting. Hold up. Who would pick E? I don't know. That's a great question. Himi says, I pick. DD. Okay. All right. Okay. If there's no questions, then let's move on to the next one. So this one's actually a really neat problem because it looks like a lot of math, but it's actually pretty much zero math. So, did anyone solve this? Any ideas? B, 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 okay. B, 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 okay, everyone's saying B. Someone tell me how they got the answer B. Maybe Jasper, how did you get B? It's okay. It's okay. We'll have time. I made the 299 all into 300. That's a great idea, Jasper. Hey, Jasper, do you want to write that out on a board or are you fine with it? You can annotate if you want. Oh, I'm saying that if you want to share your solution by writing it out on the board, you can do that by annotating. But if you don't want to, it's fine. Yeah, okay, yeah, that's good. Okay, so Jasper, you turned all of these into 300, but then how did you get rid of the extra numbers? Okay, here, I'll finish your solution for you. Okay, so basically everyone, what Jasper did was he turned these into 300s for the sake of simplicity, like this. This way you have 4 300s plus 3 300s plus 2 300s plus 1 300, which is just 10 300s. So that's 3,000. But then you got to account for the fact that you added all these numbers that weren't supposed to be added. So you got to subtract that back, right? So the first one, you added 4 ones, subtract 4. And then you added 3s, subtract that. You added 2s, subtract that. Finally added another 2, subtract that. And after doing that, you subtract a grand total of 11, which means that you would end up with 2989, which is right here. So B is correct. But there's actually another way to do this, right? That's not the only way. The other way you can do this is you don't even have to change it to 300. You can just straight out factor, right? So you can just do this. 4 plus 3 plus 2 plus 1 times 299 minus 1. And where that 1 came from right here is that I wrote the 298 as 299 minus 1, or I guess you can say 1 times 299 minus 1. And then if you factor out all of the 299s, you would end up with this surprisingly easy number to compute, right? It's just you add a 0 behind it and you end up with, oh my God, 2990 minus 1, which is, guess what? B. So again, you got to look for patterns, right? Because you do not want to just straight up compute this, because yes, you can do it, but it's going to take you a lot of time and it's going to have a high chance of error, right? So you always want to look for these patterns to make these computations easier. So again, what I just did is I made every term 299 and then I just pulled it out with the distributive property. You guys know the distributive property, right? The distributive property of like addition. You guys know that? Like yeah, exactly. It's just that. But you see, like a formula you learn from the book can actually be so useful when computing these numbers. And that's why you want to really pay attention to these patterns. Okay. Are any questions? Going once, going twice, going 3 times? All right, no, okay. Let's look at this is probably going to the last question today. All right, did anyone solve this? This is actually a really hard question. Time ran out for me. That's okay, Jasper. You're doing great. Because like usually you would have like about 10 minutes for like every set of 5 questions, but I'm just like cutting down on time right now. So like the questions you guys are solving are like great. You're doing great. Okay, someone says A, someone says B. Okay, Sean. Oh, Sheldon and Sean, you guys both got B. Do you guys want to explain how you got this answer? How did you get B? Tell us your solution. Tell us your thought process. I'll love if you unmute and talk, because typing takes forever. Oh, Sean. Oh, Sean's right there, Jasper. Sean says just added the whole numbers first then. Okay. All right. I just estimated. Right, okay, okay. Right, okay, so this looks pretty intimidating, but it's actually not too bad because you really don't have to add these numbers together. So as Sean said, the easiest way to do this is just to add the whole numbers first, right? So 2 plus 3 plus 5. Someone tell me what that is. Kimmy says 11. Oh boy. Right, it's equal to 10, right? So you take the whole numbers, you add them up, and you get 10. And then if you look at the fractions, you actually don't have to add these. Oh no, that's not good. You actually don't have to add these up because if you look at it, you see that 1/2 is definitely like 1/2, right? And when you have 1/2 and you add another 1/7 and 1/19 to it, you know that the sum is going to be greater than 1/2. But at the same time, 1/7 and 1/19 isn't that big to add up to a whole 1. So that means is less than 1. So when you combine that with the 10 above, what you get that is you'll get that this is greater than 10.5 and less than 11. So the answer is B. You're right. Very good. Are there any questions on this? People have more brain cells. All right, okay. While we still have like a bit more time, let's try one last question, okay? Yeah, maybe this one. It's not terribly hard. I'll give you like 30 seconds to do it, or I guess 1 minute. Come on, let's do it. See if you can solve it. Okay, I think most people solved it. So basically, the idea of this problem is really simple, right? If you look at this black rectangle here, you can see that it's clearly, if you draw a line through it, you can see that it's 1/6. I mean, sorry, 1/3 of this big rectangle because it's exactly 2/6 of it, which simplifies to 1/3. So that means you have 1/3 of a quarter of the rectangle, which means they simply multiply these together to get 1/12. Yep, very simple. Let's try one last question. Let's pick a hard one. I know, yeah. Let's pick a hard one, okay? Oh, here's a fun one. Let's do this. It's not too hard, but it's pretty fun. I promise this one is easier than it looks. It's not too hard. I promise. I solved it. It's not very hard. Come on, guys, it's really easy. Come on, just think. It's not very hard. It looks intimidating. There's a lot of words, but if you just think about it, it's not very hard, okay? Come on, Kimmy, you're almost there, okay? Just like 2 more minutes and we'll be done. Just try your best. Okay, I think everyone's pretty brain dead. All right, here, I'll reveal the official solution, okay? It's actually really simple, okay? So here, let's say that we have 4 chairs. 1, 2, 3, 4. And this is 1, 2, 3, 4, right? And if you just read the question, you see that they said Brett is sitting in seat 3. So they already gave you 25% of the answer, right? Brett's sitting in seat 3. And then look at how the problem says that Joe's statements are all false. Both of these are wrong. Joe's a liar. All of these are false. So that means Brett is not sitting next to Carl, but there's only 4 seats, right? If Brett is not sitting next to Carl and there's only 4 seats, that must mean that Carl is right here, right? Carl's in seat number 1. Now you see that Abby is not between Brett and Carl, right? Because Joe said that Abby is between Brett and Carl, but Joe is lying. So that means Abby is not between Brett and Carl. So she must be in 4. So guess what the answer is? D, Dana, right? It's not really that hard, guys. Like a lot of the questions on the AMC 8 look really intimidating with a lot of words, but a lot of the times you just have to think a little bit more and you'll solve it. But yeah, that's all we got for today. So unless you have more questions, you are free to go. Thank you for coming. Bye.